So hi everyone, my name is Marcos. I work at Dagger, and before starting with my demo, which is going to be around building Knative functions in Dagger and some other interesting things around it, I need to do the further sacrifice of bringing a sacrifice to the demo gods. So I brought my blue feathery scarf. This is like a carnival or wedding thing, and my feather also as well. So we'll see how this works. Hopefully it's good enough. Okay, so now that we're all set, building Knative functions with Dagger. So I'm going to try to make this demo as well. This demo is part of a story of a friend that I was collaborating with. His name is Mauricio. He's actually very involved in the Kubernetes and Knative communities. And he was talking to me about Knative, and the benefits and the things that you can do with it. And he's actually working on a book, which is called CI/CD for Kubernetes, that is coming up this year. And he has an example on where he shows how to deploy Knative functions in Kubernetes and with different pipelines, CI/CD and all that. And he told me, hey, it would be great to see if Dagger can help here, because there are some challenges that I have with my approach that I would like to see how Dagger can help us solve it. So yeah, we basically started collaborating, and what I'm going to show you now is like I have a simple Knative function here, like a Go function. So if you see the handle method, which is generally the way that you define an entry point for a serverless function, it only outputs a hello function, right, from the response of the HTTP request. For those who don't know what Knative is, as I explained before, you can see the website here, knative.dev. It's basically an open source serverless framework. There are several out there, but this is the one that, in my opinion, and for what I've seen, is the most developed one in the Kubernetes ecosystem and the cloud native one. So going back to our example, so Mauricio showed me this, and the way generally that Knative promotes and recommends building all these different functions and deploying them is through a tool that is called Func, that is part of the Knative functions project, that basically leverages different technologies like Tekton for pipelines and build packs to basically take your code to an OCI image that you can deploy later in your Kubernetes cluster. And this basically Func project, it's a small CLI that helps bootstrapping all this and making all this basically magic. So I do have the Func CLI installed in my machine. As you can see, you can actually fetch this CLI from github.com/knative/func. There are instructions on the website, I believe, on the installing part. But the idea is that once you create a function, and you create a function by doing func create, and then you select the language, I already have one here, it basically creates this func YAML file where your function definition is basically defined, right? So you can see that my function name is Dagger Knative. I'm basically setting up an OCI repository where I'm going to push the image of this function, and then some other parameters to like deploy the function, health checks, and all that. But the whole idea about this is that you can do, once you have all this set up in your machine, one important, but I would say a bit annoying requirement is that you need to have, in order to build and deploy this, you need to have Docker installed in your machine, right? Because the way that Func, builds and packages all your code into an image is by using Docker. So if I do func build, let me open the verbose output, you're going to see that Func is detecting, this is, by the way, a bit cached, so that's why it's between quotes fast. But you're going to see that Func detects the framework that my function is written in, which is Go. It's defined in the YAML file. It's using build packs, so it's basically detecting all the build packs, all the necessary build packs to build this function. And then it's going to ultimately build the Docker image, as you can see here, that is called Marcos Dagger Knative. that you can of course run it locally. So you can do docker run 8080 and this image, and you're going to see that the image is already listening in port. So I can do curl localhost 8080, and you can see the hello function output here, right? So this is what you would expect with Funk. So this is working as advertised. This actually, the workflow is very neat. One thing though that is not about Funk, but about build packs in general, and maybe someone that knows better about this because I just happen to start working with it, is that the image that it produces is quite large. So if I do Docker images, Dagger Knative, if I do this, you're going to see that the image in this case is 1 gig, which is quite a lot actually. Generally, it is way less than this. So I'm just building a single handler function, right? So this doesn't make a lot of sense. I think that for development, it bundles some other stuff, but for production deployments, it's generally leaner. But this is part of the whole build packs, usage and the builders and the different components that I have. I know that it can be optimized, but I don't know how exactly because I'm not an expert on this. But yeah, anyways, this is how you do it with Funk. And the last thing that I want to show you, which is also a bit strange that I don't know how it works, but maybe someone in the Funk community can help us understand better, is that if I run this again, right, I didn't make any change in my code. I'm running Funk build again. And for some reason, it's like rebuilding the function. As you can see, it's fetching the dependencies again. And then it's creating a new OCI image, even though I didn't change anything in my local directory, right? That's something strange to me because I would have expected, that this somehow realizes that I'm, should be using cache. So it shouldn't have done anything, right? Because I already have the image in my machine, nothing changed, etc., etc. Anyways, so Mauricio was showing me this, and then I told him, hey, but of course this has some limitation, right? It requires Docker, it has this behavior which is a bit weird, and on top of that, he was showing me that his GitHub Actions pipeline to deploy this, which is this one. All this is in a repo I can share later. But this is the pipeline that the GitHub Actions pipeline that he came up with in order to, build this code and then deploy it eventually to a Knative deployment. As you can see, I'm going to go through this very quickly. He basically installs Go, because that is the runtime that the function needs. The first thing that he was doing is scanning the code using the Anchor scan action from GitHub. Then he was uploading the results of that scan to the GitHub, basically security advisories or something. And then he has a different step, which is the package step, that is doing the same thing. It's like installing Go again. Then it's installing the Funk CLI, which is the same one that I showed before. Then it's doing a Docker login to log into the registry. Then it's scanning again, but this time it's not scanning the code locally in the project, but it's scanning the resulting OCI image because he was building the Funk image here. So he was building the image using Funk as I was doing before. He's scanning the image. He's publishing this into the OCI registry. And then he's finally publishing the container image to whatever he wants to publish it. So when I saw this, and then he was telling me, hey, Marcos, it would be great to see if Dagger can help here. Like many of newcomers to the Dagger project, the first thing that I told him is that, hey, this is great, but I do see a lot of opportunities where Dagger can help here, right? First of all, trying to escape all this YAML, madness. You have a lot of duplicated things here, like you install Go here one time, then you have your scan action here two times later afterwards. So if you need to, for example, to change this behavior for whatever reason, or you want to change the severity, you need to change it here, and you need to change it there. So you are, copying, pasting stuff. We all know the YAML limitations, right? And then there's one thing that many people do, because I think that is a behavior that GitHub Actions accidentally introduced, which is you have two jobs here, right? The build and the package. And as you can see, the package depends on the build. So what GitHub Actions is going to do is going to spin up two VMs, right? Because you have two jobs. And the second VM is going to be waiting for the first one to finish without doing anything. So the user is, and the code is going to have to be checked out twice, one here and one on the other job. And several things are going to have to be installed twice, even though these steps are sequential, right? And the way that people, the reason why people do this is because then in GitHub Actions, you have a very nice UI. I don't have this to show you now, but if you actually deploy and run this, you have a very nice UI that tells you, hey, you have a build step, and then you have a line to the package step that connects both jobs because there's a dependency of them. But under the hood, what people are doing is very inefficient because, again, you are spinning up 2 VMs. You have to install things twice. So all in all, you're making your OCI thing, your OCI pipeline being slower and more error prone, because if one of those VMs fails to start because whatever reason, I don't know, maybe the underlying cloud provider basically fails, then you have to wait for GitHub Actions to provision a new one. And, basically you're introducing more complexity, more time, and basically more repeat steps in your whole CI/CD process, which is not optimal. And many people do this without realizing the consequences that it has. But anyways, I was telling him, hey, we can totally do this with Dagger. So let's see how that would look like. So I grabbed the Go SDK because the function was created in Go again. And let me show you the initial approach that we took in order to implement this. So I basically created a very simple Go file. I didn't choose any runner, basically projects like Mage or anything, because this was simple enough, but I could have taken any approach. I just did a very, very simple main file with the different steps that the GitHub action has, like build, scan my local code. This scan function also allows me to scan remotely if I send the different input here. The package, which is the one that is going to be able to build my function, and then the push part. Let's start with the build. This is very trivial. I'm also able to build basically the code that I have locally, like using Go build, which is something that Mauricio wasn't doing on his. If you see the this step, oh no, he was doing it here. Sorry. So he was doing this, right? Go build, right? And the way that I'm doing that here is through Dagger, and as you can see, I am basically creating a Go container, right? That this is like the standard way of creating a Go container. So I could be reusing this function in everyone in my CI/CD pipelines, right? Because this is code, and as you know, code can be reused, can be tested, can be linted, and all the benefits that has. But the good thing about this is that I'm already presetting all the necessary caching directories that this requires, right? I can actually refactor this, make this function a public function of a package that I own, and people can actually reuse this to build their code, because I'm basically taking good practices of setting up proper cache mounts and all that. So the second time that I run this is going to reuse this and not pull dependencies each time. But anyways, I'm basically building the code. I'm not doing anything out of the ordinary here. So I'm going to show you how can I run this. So I do go run CI, and this is build. This is going to use Dagger in my machine, right? It's going to talk to my Docker daemon, and it's going to pull the Go image, which I already have pulled, and then it's going to send my code to the Dagger runner, and then it's going to pull the Go image, which I didn't have pulled for whatever reason, probably because of the Dagger engine version that I'm using. And then it's going to build the code, and then it's going to exit, right? So while this builds, I can show you what's next. The next step that Mauricio was doing is the scanning local on his machine. On GitHub Actions. But you are going to realize that the scanning is using a GitHub Actions, which is something that I can't reuse as of today in my pipeline, because this is a proprietary GitHub thing. But what I did is basically I checked what the GitHub Actions was doing, right? And then it's using this tool that is called Gripe, that Gripe is using. Again, I am mounting my code into the Gripe image, and then I'm running the Gripe command, which is the entry point, and then I'm outputting the same Starif file, which is a standard to define vulnerabilities in applications and OCI images, right? And then I'm writing that file to my local machine, and then I'm printing that file right here. So if my build step finishes after pulling the OCI image, should be done almost. Yeah, so this finished my code build. I can show you that I can raise an error, like if I open my handle.go and then I introduce an error here, right? And then I build again, this should tell me, hey, you have an error on your code. This should be fast because I have the image cached now. Yeah, see? So write undefined, perfect. I'm gonna go fix this. And now I can show you the scan output, right? So if I do now, instead of build, I do scan local. This is gonna, hopefully I have the gripe image pool, but we'll see. Yeah, so this is running gripe. And then I can see like a very nice JSON, which is the standard that Sarif defines of the vulnerabilities in my code. As you can see here, I don't have any vulnerabilities. We're gonna see an example with the Docker image afterwards that has some vulnerabilities. So yeah, anyways, I already have this running. I can scan my code. I have the results.sarif in my local directory. I'm gonna remove it so I'm not sending that again into the further pipelines, but I have this ready. After that, I do have the package function, and you're gonna see something interesting here, but I'm gonna show it a bit later. But the package function is very trivial, right? The only thing that I did is, as you saw before, I was using func, right, to basically package my application. In this particular case, I'm going to be using func again, right? But instead of like running locally, I'm going to run this in a container, right, which has the benefits of like any developer in my company that needs to build the func function can directly use the pipeline, and they do not need to install any particular func version, right? As I told you before, func requires, right, Docker to exist, right? So if I try to do, for example, Docker host, and then I'm going to do TCP, I'm going to basically I'm going to tell func, hey, my Docker daemon is here, but it's like an unknown address. If I try to do func build, this is going to probably complain, see, as you see, because func could not connect to my Docker daemon. So func requires Docker. This is the evidence of it. So what I had to do in Dagger in order to make this work is I had to mount my Docker socket into the Dagger pipeline. And then I'm basically copying my func binary, right? Because I don't have a Docker image for this, but I could create an image so I can distribute globally. And then I'm also copying my Docker credentials. And as you can see, as a secret, because if I want func to push the image that it produces to an OCI registry, I need these Docker credentials in order for that to happen. But I'm making this a secret, so this is secure. And then I'm basically doing func build, as you saw before, the same thing that I did locally. And then, you know, same thing as the other thing was doing. And then after this finishes, I'm basically scanning the OCI image that this produces, right? So I'm doing basically, I'm going back to the GitHub pipeline. I'm basically doing the scan that happens here below, where I'm scanning, instead of scanning my code, I'm scanning the, as you can see here, the OCI image that it gets built. So I'm going to show you this. So I'm going to do go run CI, and this is package. So this should be doing the same thing. Like the difference now is that it's going to be using func. And as you can see, it's like doing the same thing that I was doing before locally. It's detecting everything. It's building the image. So if I do, it's scanning the image now. So we're going to see that in a moment, like the results of the vulnerabilities that this huge image has. And you're going to get surprised about the amount of vulnerabilities that it has. I would really like to know that if someone knows the func project, I would like to know why the images are so big. So I have the report here, the same one that I had before. You see that I have a lot more data. So what we're going to do is I'm going to grab this report, and then I'm going to go to a website that is called Sarif Viewer. This is by Microsoft. Sarif is a standard that Microsoft is helping to push or came up with. I don't know. So I'm going to basically open this file. And as you can see here, because this image probably is not very optimized, it has like a bunch of potential security advisories that need to be addressed. But anyways, the thing is that to show you that I can actually generate the same information that the GitHub actions are doing through a very simple Dagger pipeline that anyone can run locally in their machines, right? Of course, I didn't mention this explicitly, but the benefit that this has is that anyone can run this locally in their machines without depending on GitHub actions, right? so they can see the advisories locally before pushing to like CI and wait for the CI to do all their things. But yeah, anyways, I have this running, and what I wanted to show you next is, which is something that I find really, really great, by the way. If I run this again, I think I have the SARI file. Yeah, if I remove the SARI file, because I think I didn't exclude it. Yeah, I'm not excluding this from the copy, but I could. But if I run this again, Dagger should be smart enough to realize that we don't need to build anything. See, it didn't build the Funk thing again, and it didn't run the security advisories again because everything was cached, right? So I'm basically, by doing this, I am improving the Funk behavior because Dagger realizes that, hey, nothing changed. My input files are the same ones. My Docker images are the same ones, the base ones. Everything is the same. So I don't need to go through the whole process of building the same thing again, right? So I got the output immediately, right? So this is already like a huge improvement for anyone running Funk on their any CI platforms, right? If you implement the pipelines with Dagger. So cool. I have all these things here. I already optimized a lot of this stuff. But there's one last bit, and I know I'm already like about my time, but I'm going to do this really quick. There's one piece of this part which is awesome, which is that Funk has the ability, like a lot of developers do not have a Docker daemon running locally, right? So this is like a bit of a hassle. And Funk has the ability, building functions here, if you go to their webpage, you can do local builds. And here it says that you require the Docker daemon in order to do this. But there's another thing that they have, which is called on-cluster builds, right? So basically, ideally, what they do is that if you have a Kubernetes cluster running, you need to you can tell Funk, hey, build this on Kubernetes. You need to have like a proper kubectl context configure locally to do all this. And then Funk, if you read their own cluster documentation, which is here, what Funk requires is for people to have a Tecton deployment on their clusters. So Funk is going to basically bootstrap a Tecton pipeline, which is a bunch of scripts, and it's going to trigger all the builds remotely on this Tecton pipeline, right? So then I said, okay, I set up like a kind cluster in my machine. Okay, get CRD. I have all my Tecton CRDs deployed, right? Which is maybe something that not too many people are willing to do, right? Because maybe you have Kubernetes, but you don't have Tecton. And that, of course, introduces like a big tech debt for the team if you introduce a new CI platform to your system. And what I think it's even worse, if you see the Tecton definitions, I think Tecton calls them task. I'm going to see what the Tecton definition to build like a Funk function remotely is. So if I do get task, this task, and I'm going to see the YAML, well, you're going to see it's not that friendly, right? So there's a lot of YAML with a lot of more YAML with a lot of bash inside YAML that basically, creates like a Kubernetes pod with more YAML to build stuff, right? So as you might imagine, of course, I'm complaining about YAML because I'm highlighting the benefits of migrating this to Dagger. As you can imagine, like for someone to run this, it's basically creating a Tecton pipeline that has YAML on top of it, that has bash on top of it. So to troubleshoot and to put all these pieces together is very difficult, right, for someone to do this. On top of that, which is also fun, if I try to do Funk deploy, well, there's actually a bug that I found in Funk. If I try to do Funk with one dash instead of two, for some reason it overwrites my Funk YAML. But anyways, I'm going to open an issue in the Funk repo for that. But if I do remote, check this out. So basically, seems like for some reason, Funk implemented a logic where they still do not support building Go functions locally. And the main reason for this is because the Tecton pipelines are not there yet in order to build this, right? But we can do this better with Dagger, right? I mean, the good thing about Dagger, if you already been to these community calls and if you already gone into the project, but if you don't, I'm gonna do like a quick introduction to this really fast. Is the good thing about Dagger is that Dagger can work the same way locally as it works in your local machine as it would do remotely on any VM, Kubernetes cluster, or anywhere where you can basically run the Dagger engine, right? So as you can see here, there's a link on the operator manual where it describes a high level how the architecture works. So basically, you have your client tool. In this case, would be your pipelines that connect to your session, which is in your local machine. It's basically that is basically a binary that runs in your machine that has all this logic. And the binary, when you are using it locally, it connects to a Docker container in your Docker daemon. But in our case, since Funk already requires a Kubernetes cluster to work, what we are going to do is we're going to create a pod in the Kubernetes cluster with the Dagger engine, and then I'm going to tell Dagger to build the same thing that it did locally, like the same Funk build that it did locally on that cluster instead, right? And I don't have to deploy any CRDs. I don't have to deploy any different CI/CD tool for this. I only need a pod that running Dagger. It can be a daemon set. It can be whatever you want, a deployment. And then I'm going to tell my client to connect to that remote engine. So if you see my package step here in my CI/CD pipeline, I have a flag, that it is remote. And what this is going to do is going to call the function that is called setup remote engine. By the way, we could make this function a library that anyone can use, right? Because this function is not tied to my pipeline. Like anyone could basically grab this function and do it for their own pipelines to bootstrap a pod remotely. And what this function does is very simple. It basically reads my Kubernetes config, right? I set up a namespace, right? The kube namespace, I think it's a variable that is hard-coded. Where is it? Here. Let me see. So it's here, which is by default, right? And then what I'm doing is I'm setting a name to the pod that is called Dagger engine, and then I'm checking if the pod exists, right, to use that pod. And if the pod doesn't exist, I'm calling the Kubernetes Go SDK, right, in Dagger, and I'm creating the pod, right, and then I'm setting up the pod with all the necessary volumes and security context in order for the engine to run. As you can see, it needs to run privileged. And then the important part here is that I'm setting this variable that is the variable that is going to hint my local CI tool to use the remote engine. And the way that you do this is basically described on this operator manual README if you want to know more about how to set it up. But the way that I do it basically is like by setting this variable to kube pod, and then I'm setting up the context, the namespace, and all the things that it needs. And this is going to basically use kubectl in your local machine to do it's going to do a dial standard input proxy against your running pod, and it's going to basically do all the communication for you. So to wrap this up, what I'm going to do is I'm going to go run the same thing that I did before, but I'm going to set the remote flag, right? So this is, as you can see here, is starting a remote build, is connecting to my pod, and it's doing the same thing that I did locally, right? In my pipeline. It's analyzing, it's building the image. The only difference is that instead of building the image locally, because I don't have a Docker daemon, so right, I'm not going to have the image locally. It's pushing the image to an OCI registry, and in this case, is my Docker Hub account. So if you see here, I don't know if you're going to see that the image is going to be pulled yet. So this was updated an hour ago. So when this finishes, which is again building in the remote cluster and doing all that, now it's probably uploading the image to Docker. After it finishes, it's going to start scanning, right? The same thing that I did before, but I'm going to stop this so we don't spend that much time. So it's uploading the 1-point-something gig image to Hub. I think this could probably take a while. Let me see if this got updated, maybe the manifest. Yeah, a few seconds ago. So as you can see, it's already pushing the image, right? So it finished. Now it's running the security advisories. Everything worked. The nice thing about this is that if you have a colleague like that is running the same pipelines, they're going to be using the same caching mechanism that I showed before, right? So if they're doing the same thing, right, they're going to use the layers and all that. So this is neat. So if I run it again, ideally this should be instant, unless I got some, I forgot something. See, it was just instant as I showed before. And the last thing that I wanted to show you, like the two last things, is that because I'm running this remotely, I can basically, I can not use my Docker daemon locally, right? Because I don't need it. So if I do Docker host equals TCP, like I did before, this is going to still be building again, because as you saw earlier, as I explained earlier, this does not use the Docker daemon to do anything, right? This is happening everything remotely, and it's instant because of the cache. As you can see, the scan is cached, everything is automatic. And the last thing that I wanted to show you is that probably if you're building this remotely, you're going to be using a production or testing OCI registry to push your image to. So you might say, oh, but I would really like to see if I can make all the build happen remotely, but I would like to have the Docker image locally because I want to run this somehow and test it locally, whatever. Because again, Dagger is so awesome, and it's amazing on a lot of things. When I'm building remotely, I also enable the ability to export that same OCI image that you build remotely locally. So you would do it the same way as you would do it locally, right? So I'm just calling container from the output image export, and I'm going to export it to a tar image locally, to a tar file locally. So I'm going to build remote, and then I'm going to set export. Because this is using the cache and it's so magic, it doesn't need to go through the whole build process again. It's only going to copy the tarball OCI image to my local machine. So as you can see there, it's basically downloading the tar from my Kubernetes cluster to my local machine. It's only 159 megs, so this should be fairly fast. And I'm checking my notes to see if I'm forgetting anything. No, I'm not. This is the last thing. After this finishes, yeah, 141, 149, almost there. Yeah.
While we're waiting,
this is sending.
Garo was asking where we can find the code for this.
Yeah, there's a repository that's called Marcos/Dagger Knative. You have everything here. We can share it in the notes after the session. So, okay, this is scanning again. There, it finished. And I have a Dagger Knative tar file in my folder now because I exported locally, so I can do docker load, this -i. This imported the image that I just built remotely in my Docker daemon, which is this SHA, and then I can do, to finalize this, to make sure that it works, I can do docker run 8080, that image, and then if I curl locally, everything works. Thank you, Demogods, for being so nice with me. That's it.